Hello everyone, today we will report about glass fracture. But first, let's define glass.
Glass. Meron tayong matibay at madaling mabasag na glass. May transparent at semi-transparent na gawa sa sand na may soda, lime at iba pa ingredients. Glass is used to make windows, drinking containers, and other articles. Ang glass ay gawa sa tatlong materials. Sand, that is silicon dioxide, limestone, that is calcium carbonate, and last, sodium carbonate. Glass fragment. Ito ay mahalaga sa isang investigasyon, katulad sa mga kasong pagnanakaw, akyat bahay, hit and run, at iba pa. Ito ay pwedeng maging direct evidence or mag-lead sa atin kung sino, saan, at paano nangyari ang aksidente. Pero nakadepende pa din yun sa kakayahan natin o sa kaalaman natin sa mga bagay na to. At kung magawa natin ng tama ang pag-collect at pag-examine, malaki ang tulong nito sa kaso. Glass fractures and glass fragments. Pwede silang magbigay ng information katulad ng isang parte ng basag na glass. Posibleng galing yon sa headlight ng kotseng na aksidente o dun sa ibang kotseng kasama sa na aksidente. Meron tayong 8 klase ng glass. We have soda lime glass. Ito ay ginagamit sa paggawa ng drinking bottles, bumbilya at iba pa. Soda lid glass, ito naman sa mga wine glasses, fine dining at figurines na kapag natatamaan ng liwanag, meron siyang white, blue at color fluorescence. Sa borosilicate glass, ito naman yung ginagamit sa kitchen, sa pagbibake at ginagamit din siya sa laboratory. Itong glass na to ay kahit mainitan ng sobra hindi siya agad mababasag. Same lang sila ng soda lime glass pero mas pinatibay to. Na kahit ilagay siya sa freezer at binuhusan mo ng mainit na tubig, hindi siya magbe-break. Fused silica glass. Ginagamit naman siya sa mga windows, lenses, UV and IR transmitting. Sa colored glass naman, ito naman ginagamit pang dekorasyon. Pwede siyang sa bottle at pwede rin to sa mga salamin ng mga church. Yung makikita natin na makukulay doon. Laminated glass. Ito naman sa mga windshield ng mga kotse. Ito ay safety glass na kahit nag-crack siya, hindi siya agad nagsha-shattered. Hindi ginagamit din to sa mga companies at window sa bahay-bahay laban sa mga natural disaster like storm. Tempered glass. Ito naman ay single panes na mahirap din mag-break o mabasag. At kung mabasag man siya in strong force ay magiging itsura niya ay parang siyang small pieces ng mga pebbles. Mas pinatibay siya sa ordinary glass. Bulletproof glass. Ito ay may combination ng 2 or more types of glass na may soft at may hard. Yung soft layer ay nagpapa-flexible ng glass para hindi siya mag-shatter agad. Ang kapal ng glass na ito ay mula 3/4 inch to 3 inches.
Hello everyone, I am Benj John Paul and now I will discuss how does glass break. When force is applied on any surface of glass, it bends, but since the elasticity of glass is limited, ultimately, it gets fractured after the threshold force application. Ang ibig sabihin lang nito, nasisira ang glass dahil may in-apply na force o impact at sa lakas nito, hindi na nakayanan ng integrity ng glass kaya nag-break. Makikita natin sa picture sa gilid kung paano nasisira ang glass. Figure 1 ng picture, makikita natin na may in-apply na force sa glass. At sa figure 2, unting-unting nasisira ang glass at di na nakayanan ito ng glass kaya nag-crack. Sa figure 3 naman, makikita natin yung mga crack na sanhi ng force. Ang tawag kung saan na-apply ang force ay ang point of impact. An investigator often has to decide whether a pane of glass was broken from outside or inside, whether it was broken with a bullet or with a blunt object. Importanteng malaman ng investigador kung ano ang ginamit na weapon para malaman nila kung ano ang dapat nilang hanapin at imbestigahan. Malalaman lang nila ito pag na-analyze na ang glass. Impact of force on glass. Impact causes a pane of glass to bulge. Side opposite, the impact will stretch more and rupture first. Radial cracks are rapidly propagated in short segment from point of impact. Elasticity permits bending until radial cracks form on the opposite side of the pores. Continuous force places tension on the front surface pore side, forming the concentric cracks, radial and concentric cracks. Dito, pinapakita kung anong uri ng crack o fracture ang makikita sa point of impact. Ito ay radial at concentric. Ang radial ay nangyayari simula sa point of impact palayo dito. Ang concentric naman ay ang nakapalibot sa radial line. Ngayon naman, alamin natin ang types of fracture impact. Low velocity impact fracture. A low velocity projectile produces cracks in the glass which radiate outward from the point of impact, radial crack. If a pane is firmly held on all sides, concentric cracks can form around the point of impact. By observing the Waller lines, ridges on the radial cracks, the direction of breaking force can often be determined. Observe only the Waller lines on the radial cracks nearest the point of impact. Ang low velocity impact ay nangyayari lang pag ang glass ay tinamaan ng mababagal na bagay tulad ng bato, martilyo at iba pa. Ito ay nagkakaroon ng radial at concentric cracks. High velocity impact fracture. A high-speed projectile striking a piece of glass will produce a cone or crater. If the projectile passes through the glass, the opening on the exit side will be larger than the opening on the entry side. The size of the hole and the diameter of the crater cannot be used to reliably predict the size of the projectile. Projectiles that passes through the glass at an angle to the surface produce an elongated hole. Radial cracks may also develop from high velocity impact. High velocity impact, nangyayari ito dahil sa mga mabilis o high velocity projectile tulad ng bala na nanggaling sa baril. Pag tinamaan ng glass ng high velocity projectile, pagkakaroon ito ng tinatawag na cone fracture. Nangyayari lang ang cone fracture pag tinamaan ng mabilis na bagay ang glass. Thermal fracture. In non-tempered glass, a typical heat crack is curved, has a smooth edge, and has no indication of point of origin of the crack. If a pane of glass has been cracked by the action of heat, it shows characteristic long wavy fracture. When glass is exposed to fire, it begins to melt at about 1200 degree Fahrenheit. It becomes runny at about 1600 degree Fahrenheit. Glass that contains many cracks indicates a rapid heat buildup. Glass that is heavily stained indicates a slow, smoky fire. Thermal fracture, nangyayari ito dahil sa natural climate o natural heat at wala kang makikita na point of impact sa thermal fracture. At dahil wala itong point of impact, wala din itong radial at concentric cracks. Ang makikita mo lang ay wave or wavy pattern fracture. Makikita sa gilid ang glass na nag-crack dahil sa init. Makikita sa picture na ang glass ay walang point of impact, walang radial, concentric cracks. Pero meron kang makikita na wavy pattern.
Types of fractures. Ang radial cracks at concentric cracks, halos hand-in-hand sila. For example, nagbato ako ng matigas na bagay sa glass. Yung lines na parang ugat mula sa center na pinagbatuhan ko, ayun yung tinatawag natin na radial cracks. Yung concentric cracks naman, yun yung mga circular cracks. Sila yung secondary cracks na nag-a-appear after magka-radial cracks. Cone fractures. Ito naman ay galing sa high-velocity projectiles tulad ng bala. Ang cone ay parang apa ng ice cream. For example, bumaril ako sa glass, so yung dulo ng ice cream cone, yun yung entrance ng bala. Yung entrance hole, yun yung may small hole at smooth surface. At yung exit hole naman, yun yung malaking hole tapos magaspang yung surface.
Glass as forensic evidence. Glass is forensically important. It is found at most crime scenes. For example, sa pagnanakaw, pwedeng basagin ng suspect ang glass window para makapasok o sa isang car accidents. Pwedeng mabasag ang windshield at iba pa. It can be carried away from scene undetected. For example, pwedeng may mapuntang piraso ng glass sa damit at sapatos ng suspect nang di niya nalalaman. It is stable, does not decay, as a glass evidence contributes to the pool of evidence. Important to collect proper known samples so incidental glass can be eliminated. Glass analysis. A forensic glass analysis is typically a comparison of two or more glass fragments in attempt to determine if they originated from different sources. Glass type determination. This type of determination compares a known sample to a glass fragment to see if the two samples came from the same source. Glass type determination. Dito, pinagkukumpara na examiner yung mga glass na galing sa crime scene. Sinusuri dito kung anong uri ng glass ang nakuha. For example, soda lime glass ba ito, laminated o tempered at iba pa, para malaman nila kung parehas ba ito sa nakuha sa crime scene o hindi, para matanggal kaagad yung di related. Sinusuri din nila ang hugis, kapal, kulay, density ng glass at ang refractive index. Ang refractive index is how light passes through the glass. Direction of force determination. This method determines which direction a projectile went through the glass by evaluating radial fractures in the glass fracture first concentric ring. Direction of force. Sinusuri naman dito kung saan galing at saang anggulo tumira ang shooter. Kung sa loob ba galing o sa labas, sa kanan o kaliwa, taas o baba. For example, sa isang shooting incident, madali mong malaman kung sa labas o loob ba galing ang bala. Ang kailangan mo lang tignan ay ang exit at entry hole ng bala dahil mas malaki ang butas ng exit hole kaysa entry hole. Ngayon, tignan natin ang picture ng isang bullet hole. Sa picture, makikita na mas malaki ang exit hole kaysa entry hole. Kaya madaling malaman kung sa labas ba o loob bumaril ang shooter. Malalaman mo rin dito ang posisyon ng shooter. Pagpantay o evenly distributed ang radial at concentric crack sa paligid ng butas, tinatawag itong perpendicular shot. Ano nga ba ang perpendicular shot? Perpendicular shot exhibit an even distribution of chipping on the exit side of the glass. Projectiles that passes through the glass at an angle to the surface produce an elongated hole. Sa susunod na picture naman, makikita natin kung ano ang anggulo ng shooter. Paano mo ba malalaman kung ano ang anggulo ng shooter? Angle from the right. Heavy flaking or chipping on the left side of the glass. Makikita sa picture sa taas na bumaril ang shooter mula sa kanan. Ang una mong mapapansin sa bullet hole, hindi pantay ang pagkakadistribute ng radial at concentric sa paligid ng bullet hole. Mapapansin na pag bumaril ang shooter sa kanan, mas malaki ang sira ng left side ng exit hole. Sa baba naman, tumira ang shooter mula sa kaliwa. Angle from the left, left to right. Heavy flaking or chipping on the right side of the glass. Pag bumaril naman sa kaliwa, mas malaki ang sira ng right side ng exit hole. Ngayon naman, alamin natin ang sequence of force. Sequence of force determination. An examiner can establish the sequence of shot by considering the radial fracture termination points. The first shot radial fracture will extend completely while the subsequent shot radial fracture will be stopped or cut as they come into contact with prior fracture. Sequence of force. Sinusuri dito ang pagkasunod-sunod ng point of impact sa glass. Para malaman ang pagkasunod-sunod, kailangan mo tignan ang radial line. Sa picture na ipapakita ko, susuriin natin kung ano ang sequence of fracture. Sa picture, makikita natin ang tatlong point of impact, A, B, and C. Ang una nating gagawin is tignan ang mga radial lines ng tatlo. Kasi, ang pinakaunang radial lines ay pipigilan ang bagong radial lines. O, an existing radial lines will stop a new radial lines. Masasabi natin na ang pinakauna sa tatlo ay ang A. Makikita natin na ang radial line ni B and C ay nag-end sa radial line ni A. Ang pangalawa naman ay ang B, kasi nag-end ang radial line ni C sa radial line ni B at A. So, ang order of events ay nauna si A na tumama sa glass, pangalawa si B, at panghuli si C. May dalawa pa akong ipapakita na picture. Sa picture sa taas, makikita natin ang 4 na point of impact. Kung susuriin natin ang radial lines ng bawat isa, makikita natin na ang radial line ng A tinerminate o tinapos ang radial lines ng D, C, B. Kaya masasabi natin na ang A ang nauna. Sa picture, makikita naman natin na di nag-meet ang radial lines ni B at D. Kaya di natin malalaman kung ano ang nauna. Pero pag tinignan natin ang radial lines ng C, makikita natin na ang radial lines nito ay nag-end sa radial line ng D. Kaya masasabi natin na nauna si D kaysa kay C. Ang radial line naman ni B ay nag-end sa radial lines ni C. Kaya nauna si C kaysa sa B. So pangalawa ngayon si D, pangatlo si C, panguli ang B. Ang sequence ng order ay A, D, C, B. Sa picture sa baba, ang sequence ng order ay nauna si B, pwedeng pangalawa ang A at D, pangatlo ang E, panguli naman ang C. Ang sequence ng order ay B, A or D, E, at panghuli ang C. Ngayon, alamin natin ang significance of glass and glass fracture evidence. Glass evidence can help to aid the reconstruction of crime scene, to provide information about the events which took place, and assisting in proving or disproving a witness story. Glass fracture patterns are associated with burglary, criminal mischief, shooting incidents, and fire scene. To evaluate the direction of impact force applied from inside out or outside in. To calculate approximate force of impact, angle of impact force. To determine the type of glass fracture, the sequence of firing, direction of fire, and the type of firearm for the projectile holes present. Fracture patterns are unique. Pieces from the broken glass pane or hole show marks that are characteristic of the type of injury and direction of force. If correctly interpreted, these findings give useful information about the object used for breaking and velocity of breaking object. Fracture examination can provide information as to the direction of the breaking force and the sequence of multiple impacts. A piece of glass evidence is not just a glass, it can tell a different story of what happened in the crime scene. Collecting and handling glass. The procedure used in the search for and collection of glass and glass fragments are in general the same as those used for the other types of evidence. Differences are due to the nature of glass itself and to the investigative and evidentiary findings to be sought from it. Records. As with the other types of evidence, glass and glass fragments must be photographed and their location noted on the crime scene sketch. Before they are touched or moved, pertinent data must be recorded in your notes concerning the glass and any obvious, suspected, or hypothetically relation it has to be to the incident under investigation. Ang pagkolekta ng glass evidence ay parehas lang sa pagkolekta ng ibang evidence. Ang dapat mo lang tandaan ay ang golden rule of crime scene. Do not touch, move, change, or alter anything until it has been identified, measured, and photographed. Collection of glass evidence. Number 1. Identify and photograph any glass samples before moving them. 2. Collect the largest fragments that can be reasonably collected para mas mapabilis ang pag-analyze ng glass. 3. Identify the outside and inside surface of any glass. 4. If multiple paints are involved, make a diagram para di malito sa pag-analyze ng glass pag marami. Number 5. Note trace evidence such as skin, hair, blood, and fibers. 6. Package all materials collected to maintain the chain of custody. 7. The glass fragment should be packaged in boxes to avoid further breakage. 8. If evidence is to be examined for glass fragments, it should be taken whole and each item individually wrapped in paper and box. 9. If even the remotest possibility exists that the glass fragments may be pieced together, if every effort must be made to collect all glass fragments para mas makatulong sa pag-iimbestiga kung posible mang mabuo ito. Number 10. Submit glass evidence along with a representative sample of each type of glass from the crime scene para maging reference ito sa pagkukumpara ng mga glass galing sa crime scene. That is all. Thank you for listening.